In this video, we are going to focus on similar triangles. We are still busy with geometry of 2D shapes. In the previous video, we focused on congruent triangles. Now, similar triangles contains the letter M in similar, and that M you can think of as minimi and maximi. So it is basically if you have two triangles that have the same shape but different sizes, but the sizes are in proportion. So in other words, there are basically two ways to prove similarity. One is to look at the shape, and the shape as measured by the angles. So in other words, if all the corresponding angles are equal, so in other words, if these two angles are equal in size, and if these angles are equal in size and the final set of angles are equal in size, then it would be similar triangles. This one will just be the bigger version of the other one. Or let's say this side is 10 units and the corresponding one is 5. Let's say this side is 8 units and the corresponding one is 4 units. Let's say this one is 6 units and the corresponding one is 3. So you can see the sizes are proportional. That for the big triangle, it's always the corresponding leg is double that of the smaller triangle. So therefore, if all the sides are in proportion, that will also be a sufficient way to prove similarity. So there are two scenarios. Either you have angle, 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 or you have to show that basically all the sides are proportional. So with this knowledge, let's illustrate this by tackling exercise 13.8, the first number, and for A we have to prove that each pair of triangles is similar. So we can see we already have a matching angle here, 27 degrees. Since we don't have lengths of sides but only angles, we will probably have to show that angle, angle, angle apply in this case. So we already have one angle. In this triangle we have two of the three angles. In this triangle similarly we have two of the three angles. So we can use the property of triangles to get the third angle. So we can say in triangle DEF that angle F equals 180 degrees minus the 63 degrees minus the 27 degrees due to angle sum of triangle. And then we will find that F is, let's just see, 60 and 20 is 80 plus 10 is 90, F is 90 degrees. And now here we already have in triangle ABC a 90 degree and the 27 degree, so therefore we know A will have to be 63 degrees. So in a similar way, we could have said in triangle ABC that angle A equals 63 degrees due to the angle sum of the triangle. So now to prove similarity, we follow the same outlay as for, or outline as for proving congruency. We also have the introduction, namely in triangle ABC and triangle. And now, just as in congruency, order is important. So angle A is the 63-degree angle, so we need the corresponding angle in DEF is angle E, which is also 63 degrees. Angle B is 90, so we need angle F. And then angle C is 27, so we need angle D. So we have our introduction, now we have our body, which also have 3 parts. So firstly, we can say that angle D, or rather angle C, equals angle D. That was given to us. Secondly, we can say that angle B is equal to angle F, as shown previously. And thirdly, we can say angle A equals angle E, also as shown previously. So now that we are done with our body, we can write our conclusion. Therefore, triangle ABC is similar, so the sign for similar is like a parallel one, but with a third vertical line. So it's similar to triangle EFD. Now that we have proven that triangle ABC is similar to triangle EFD, we focus on number B. If AB equals 4 units, so AB is 4 units, BC equals 8 units, BC, and EF equals 2 units. Firstly, calculate AC with reasons. So we firstly have to calculate AC with reasons. Leave your answer as assert. So now what I already detect in triangle ABC is we have 2 of the 3 lengths. We have a 90-degree triangle, so we can use Pythagoras to get the third length. So we can say in triangle ABC, we know that opposite the 90 degree is the hypotenuse, the longest side. We square that according to Mr. Pythagoras. So B squared equals to A squared plus C squared from Pythagoras. So now B squared is what we need. We know we can replace A with 8. So we have 8 squared plus c squared. C we know we can replace with 4. So we have plus 4 squared. So therefore b squared equals 64. 4 times 4 is 16. So b squared equals 100. No. 60 plus 10 is 70. 4 plus 6 it's 80. Okay. But now we know that 16 can go into 80 5 times. So can say we can take the square root of both, so that we just simply have b, but now we can rewrite 80 as 16 times 5, and we know the square root of 16 is 4, so it's 4 square root 5. Insert 4. Okay, so we have the answer for number 1, because P we know is equal to AC. So let's focus on number 2, where we need to determine the lengths of DF and DE with reasons. So now we can make use of similarity. We can now say that we know the length of AB as a proportion to EF must be the same proportion as the length of BC to FD, BC to FD, which must be the same proportion as AC, length of AC to ED. We know all of this due to the similarity of ABC to triangle EFD. So now AB we know is 4, so we have 4. EF is 2. BC is 8. FD is one of those that we have to determine. AC we calculated in number 1. It's 4 square root 5. ED is the one that we also have to calculate. So now 4 divided by 2 we know is 2. So we know triangle ABC is bigger than triangle EFD by a factor of 2. So therefore FD, so FD must be half of the size of BC. So therefore, if BC is 8, then FD will have to be 4. So we know FD equals 4. And similarly, we know that ED must be half the size of AC. So we have 4 square root 5 divided by 2, which is equal to 2 square root 5. Now we are moving on to the second pair of triangles that, according to A, we have to prove are similar. So in this specific case, we have a 90-degree angle that corresponds, and then we are given 2 side lengths. So it seems there are more side lengths than angles, so we probably will have to work with showing that all sides are proportional. The 90-degree angle is an indication that we could use Pythagoras. Since we have 2 of the 3 sides with Pythagoras, it will be possible to calculate the third one. So that will be my starting point. So in triangle IGH, I can say that opposite big I we have small I, so we have the hypotenuse squared, so I squared equals opposite big H we have small h plus opposite big G we have small g. So we have to square the g. This is according to Pythagoras, which says take the square of the longer side, that must equal to the sum of the squares of the 2 shorter sides. Now we know I is 5, so we can substitute. So 5 squared equals, we don't know h, we keep as is, but we know g is equal to 3. We have to still square that. So therefore 25 equals h squared plus 9. We can swim across the river, so 25 minus 9 is 16, so h squared is 16, therefore h equals 4. We take the square root on both sides. So we know h is equal to 4. Similarly, in triangle JKL, we know that we have small l opposite big L, we have a 90-degree angle, so again we can use Pythagoras, so L squared equals opposite big K, we have small k, is equal to K squared, opposite big J, we have small j. This is according to Pythagoras. So now we don't know L, that's the unknown, keep as is. In the place of K we have 8, so we have 8 squared. In the place of J we have 6, so we still have to square the 6. So therefore L squared is 64 plus 36. Therefore L squared is 90 plus 10 is 100. We can take the square root on both sides. So therefore L equals 10 units. So now that we have all the applicable sides, we can say in triangle. Okay, now let's just get the order correct. Okay, let's start with IGH. in triangle IGH and triangle. Okay, so I is the 90 degrees, so we need L here that is the 90 degrees. Okay, now let's just see what proportions we can see. I see 10 is the hypotenuse, it matches with the other hypotenuse, so we know 10 is double 5. So we know 6 is double 3, so those must be corresponding sides. And 8 is double 4. So IG is the one with 4, so we need now the one with 8, so it's LJ. So it's triangle LJK. So now we are ready for the body, now that the introduction is done. So firstly, we can compare IJ as a ratio to LJ. So IJ is a ratio to LJ equals, so IG is equal to 4, LJ is 8, so it's 2. Secondly, we have GH as a ratio to JK. So GH is 5, JK is 10, so it's 1 over 2. I see here we actually had 1 over 2. And then thirdly, we have IH as a ratio to LK. IH is 3, LK is 6. So since all 3 is a half, we can therefore as a conclusion say, therefore triangle IGH is similar to triangle LJK, sides proportional is our reason.